Now that we've covered the basics of recording and working with MIDI and Logic, I'll talk about MIDI signal flow and how the MIDI signal actually works. One element that can be confusing about MIDI if you're new to this is that MIDI messages do not contain any audio data. So a MIDI recording or sequence is actually just a series of control messages that trigger software or hardware synthesizers to play. That's why when you have an empty software instrument selected and you play notes on your MIDI controller or play a MIDI sequence through it, you hear nothing because there's no synthesizer to interpret the MIDI data. So let's go through the MIDI signal flow of how MIDI information is sequenced and interpreted by Logic. So the first step in the signal chain is your MIDI controller, typically connected via USB. This is normally referred to as a physical input. This inputs MIDI data into Logic's sequencer input, which interprets the digital data as musical information. Now this can split off in two ways, as a live performance or recorded as a MIDI sequence in the form of a MIDI region in Logic. Now you'd think that the next step would be the software instrument to interpret the musical data as sound, but it's not. It's actually Logic's MIDI effects. Things like arpeggiators, transposers, and note repeaters. Anything that can further transform the MIDI data before it's converted to sound. Next in the signal chain is the software instrument or synthesizers. By the way, I tend to use the terms software instrument and software synthesizer synonymously when it comes to working with software instruments in Logic. At the output of this stage, we no longer have MIDI data, we have an audio signal because the synthesizer converts MIDI musical and control data into notes, volume, effects controls, etc. Next up are audio effects inserts. These are things like EQ, compression, reverb, etc. Anything that processes the audio signal. We're going to skip the sends for now, but I'll come back to them in just a moment. So you'd think the next thing in the signal chain would be pan, but it's actually volume control that comes before pan. Then after volume is your pan control. Now this is audio panning, not MIDI panning. However, the pan values shown on the channel strip do represent a MIDI message range of 128 total values. However, we'll talk about that more in the next video. For now, just know that -64 is all the way to the left and +63 is all the way to the right. After pan, you have your output selector, which sends the audio signal to the selected output of the audio interface, and then eventually to your speakers or headphones. So where do the sends fit in all of this? Well, really three different places. They can be post-pan, which is the default setting, and this puts them after the volume and pan controls. They can be post-fader, which puts them after volume but before pan. And they can be pre-fader, which puts them before both the volume and pan controls. Each of these will have a different effect on the signal that is sent. So let's talk about what sends actually do. They split the signal off from the main signal flow chain and typically are sent to auxiliary channel strips, or aux tracks as they're known, for additional processing. If you're already familiar with mixing techniques, it's very common to use sends and aux tracks to add reverb, delay, or other time-based effects instead of applying them directly to the channel strip. This allows you to have individual wet and dry faders to mix the signal. Then the aux track's output can be routed via the output selector to the same output as the software instrument track.